Hello, this is Leighton Mitchell from the Department of Water Level Detection at Insert Creative Name here. We are in the process of designing a device which will monitor the water level in a container and then send an email whenever the level goes below 50%. We came to the conclusion as a group that any water level detection system would have to consist of two parts. The first part would be a device that gauges the water level and converts it into electronic signals. The second part would be a computer of some sort that could make sense of these electrical signals and then give readings and send emails at the appropriate time. For our computer component, we decided that using an Arduino was the optimal option. We ended up deciding to use the Arduino Uno Wi-Fi Rev 2 as the brains of the system for all three of our potential designs. The Arduino has a Wi-Fi card to allow us to send emails from it, and it has different pins located on it to interface with various electronics. We then came up with three different methods for water level detection. Our first idea for how to detect the water level of a body of water was to use water presence sensors located at various heights on the container. One could then place them every 10% mark or every quarter mark on the tank and get a reading depending on which sensors are tripped. The major advantage of this design would be that there are no moving parts, which would increase reliability and the simplicity of the design. The major disadvantage of this would have to be that acquiring water pressure sensors that fit our needs is quite difficult, and also that this would be the least accurate way to measure the water level. Our second design consisted of a scale of some sort underneath the water container. One could then find the water level simply by gauging the weight of the water. The advantage of this design is that it has the potential to be the most accurate, assuming one knows the gravitational acceleration of the current area they are in geographically, and also the exact type of water being used. The cons of this design would be that different water than what the machine is calibrated for would make it inaccurate, and also that it would be incredibly difficult to get a scale to interface with an Arduino or other computer to produce a useful reading. We ultimately decided on a third and final design, which consists of a float on a lever. This is the same method used in car gas tanks. This lever would be attached to a potentiometer, which would then be easy to connect to the Arduino, allowing us to read the water level. The advantage of this design is that it is fairly simple and accurate, and it is also the cheapest. The only con to this design is that it involves moving parts that could break or malfunction, but that problem could be easy to remedy with good construction and design. We ended up putting together a bill of materials based upon this final design. Our design consists, of course, of the Arduino and the necessary accessories like an AC adapter. We also needed special breadboard wires to allow us to connect to the potentiometer and Arduino without soldering. We then acquired a free potentiometer from the electrical engineering department. We decided to use a foam cooler as the water vessel to measure because it was not too narrow so that the float could fit. The design consists of a toilet plunger float connected to the potentiometer. We then also acquired various wood pieces for mounting purposes. As you can see in this diagram, the toilet float turns the potentiometer as the water level changes, thus allowing us to read the values on the Arduino and send emails based on that info. On Thursday, October 24th, we will order and obtain all the parts on the previous bill of materials I just showed you. On the 29th, we will assemble the float and potentiometer to the cooler. On the 31st, we will connect the Arduino and complete the programming segment of the build. Finally, on November 5th, we will finish the complete prototype and video the performance of the first hardware iteration. Thank you very much for watching.